Okay, do you hear me? That's the usual question. Do you hear me well? Yes? Okay, sorry, academician Nyanji told me it's already past time, so we need to be very, very quick. So we're going to have a session that is focusing on negative ocean carbon emissions. And it is probably actually my last speech at the Conference of Parties. I'm very, very glad to moderate this panel. My first time at COP was in 2015 when ocean got on the agenda of United Nations Convention on Climate Change on the Paris Agreement. And I think since then we have been progressing very, very strongly on including ocean on the agenda of climate negotiations. And of course, Ocean Pavilion, once again, thank you Scripps, thank you Hui for organizing this, and we see a lot of champions here. So, I will give you a very brief introduction to the topic, but in a quite philosophical way, because they'll be immersed in a lot of technical things and science. So the history of our civilization is basically competition for power and for ability to consume well, and a lot of conventions that exist now are, I would say, symptomatic in the sense that we created a problem, we're trying to solve the problem without kind of find a way forward, without creating a problem. In my view, and I used to be a hardcore scientist, engineer, so I, for example, was involved in design of the first gas pipeline from the Arctic, for which I apologize, like Antonio Guterres apologized to young people that we are not living the best the world for them. So, but now I think I turned into social scientist, and ocean helped us to understand the complexity, understand also human values. So only human values will be able basically to take us forward. But at the same time, we are in a very difficult situation with emissions. Climate is warming. Emissions are not getting reduced. So the first mantra is very, very important. MCDR is not an alternative. Removing carbon from the Earth system is not the way forward, because we need, first of all, to keep trying to cut emissions. But at the same time, the risks to the climate system, to the Earth system, to Mother Nature are so significant that we are now pursuing, once again, geoengineering approaches, including the science for those approaches. And the science, that science definitely has to be complex. It has to be very, very responsible. And I would like to say that the new developments in addressing this science, the needs for science, conditions are forming now. They're yet still, I would say, in the infancy, but the recent AGU guidelines for ethics of research in the climate intervention are helpful. So they basically setting the goal of this, the right governance of this, the precautionary principle, and basically, we need, I think, to very seriously think about engineering, but also put it in the philosophical and governance context for that. And we are going actually to have two sessions that are focusing on MCDR. And one of them is this session and with leaders in this field. And the other session will be half hour later after the finish of this session. So the second session will be focusing on the risks, potential risks associated with MCDR. I think the full picture you will get if only attend two sessions and see what are the prospects and what may be the risks. And only by having a dialogue between the communities that understand both the potential solutions and also the risks, we will be able to move forward. So all this group of people, I'm going to introduce them soon. No, they're working on solutions for climate, for the ocean, and what unites them is the fact that they are all recognized participants in the Decade of Ocean Science for Sustainable Development, because the decade has a challenge number 5, Ocean Climate Nexus, and so they are recognized leaders of activities that are in turn recognized by the Ocean Decade. So that's the team. I used to be the executive secretary of the Environmental Oceanographic Commission of UNESCO. Now I'm advising SCRIPS on various matters. We're going to have the first speaker, who is His Excellency Ambassador Peter Thompson, United Nations Secretary General Special Envoy for the ocean. Then Professor Nianji Jiao, who is academician of the Chinese Academy of Sciences, will speak about Global Once, a major program in the decade. Then Leonardo Valenzuela Perez, who is a PhD, who is a key person in the Ocean Vision. He's going to speak about activities that Ocean Vision is doing also for the decade. Noah Lenning will take over presenting a very interesting concept that they developed in terms of the organization called Rewind. And then Yernan Selibayev from Caspian Eco will add a kind of local flavor to the whole thing, presenting to you nature-based solutions related also to carbon dioxide removal. So with that, I would like to give the floor to Peter Thompson and to put us on the right track, as he always does.
Morning, ladies and gentlemen. Just looking at the audience, I think we've got a mixture of science and policy here. So I'm not a scientist, and we've got some very eminent ones here. So basically what you'll get from me is a bit of a 5-minute blast on the policy side of things, and then I'll hand it over to the scientists. You don't need me to recite to you anymore the long litany of symptoms of the measurably declining health of the ocean. You don't need that anymore. We're awake to it. And I think we're all broadly aware of what ails the ocean and our relationship with it. Definitely, we can all benefit from digging down deeper into the cause and effect of those symptoms. But the prevalent preoccupation now has moved on to one of, what are we going to do about it? And because that litany of woes is primarily anthropogenic in origin, the main question is how are we going to change our ways? That was put some time ago by Sir Martin Rees, the Astronomer Royal of UK, as what are we going to relinquish? That's really the big question. I think the short answer, or should I say the prevailing wisdom, is that we've got to undertake the so-called green transition without delay. We've got to move to sustainable economic models operating within ecological planetary boundaries. We don't need the greenwashing status quo to tell us that the transition is complicated. We know it is, but so is life, and that doesn't stop us wanting to live life to the full. However difficult it may seem, transitioning away from the use of fossil fuels is the fundamental change that's necessary if we're going to overcome the truly existential challenges our grandchildren will face on this fast-changing planet. So, colleagues, we're called upon to increase our understanding of the potential of ocean-negative emission technologies to help us grasp the nettle of carbon dioxide removal, so-called CDR. At this stage, let's remind ourselves that the IPCC says that while CDR cannot substitute for immediate and deep emissions reductions, it is part of all model scenarios that limit global warming to 2 degrees or lower by 2100. Marine CDR is therefore stepping into the arena with its fair share of proponents and detractors, with much clarification still required to correctly define the term in order for it to be more clearly understood by the general public. It's essential that by the time we reach the 3rd UN Ocean Conference in Nice next year, that we are fully informed on the benefits and the risks of the various forms of so-called marine CDR being put forward around the world. Some have merit and some are manifestly too risky. And so the task of analysis and recommendation has been put upon the One Ocean Science Congress that will meet in the week preceding the UN Ocean Conference, and good preparatory work to that effect is well underway, and I'm sure many people in this room are going to be part of that One Ocean Science Congress. The proponents of ocean negative carbon emissions are advancing strategies that can remove carbon from the atmosphere and can also improve marine ecosystems. Their solutions offer dual benefits. They address pollution and transform degraded marine areas, such as those suffering from eutrophication, hypoxia, or acidification, into functional carbon sinks. In so doing, pollution scenarios are turned into carbon sink projects, thereby creating a healthier ocean while mitigating climate change. They also bring to our attention to other sources of emissions, such as wastewater treatment plants. Traditionally seen as carbon sources and cost centers, they demonstrate that these facilities can be reimagined through interdisciplinary innovations into being carbon sinks and profit centers by integrating negative emission technologies. The key to realizing these ambitious goals lies in an interdisciplinary approach. Science alone cannot solve the climate crisis. We need to integrate the expertise of engineers and marine biologists, economists and policymakers and innovators. Together we can design solutions that are technically viable, legally compliant, and economically sustainable. And of course, international cooperation will be essential to scale these innovations and ensure that they're accessible to all nations, particularly those most vulnerable to the climate crisis. Ladies and gentlemen, my esteemed colleague Vladimir Ryabinin was instrumental in bringing the UN Decade of Ocean Science to the UN General Assembly for adoption. This was a massive step forward for ocean science. And as we approach the halfway point of the decade, we can see that ocean science is now receiving more investment and attention than ever before in human history. I'm sure you've heard the mantra, there can be no healthy planet without a healthy ocean, and the ocean's health is currently measurably in decline. Well, as parents and grandparents, we're summoned by the principle of intergenerational justice to halt and reverse that decline. So aggravating this perspective is the clear statement in the State of the Ocean report, which was issued by the Intergovernmental Oceanographic Commission in 2022, that said, currently the quantitative description of the ocean is drastically incomplete. And as a result, current knowledge is insufficient to effectively inform solutions to the ocean that humanity is facing, end of quote. At a time when solutions are so desperately needed, we find our knowledge is insufficient. And so in the face of the hugely important scientific challenges and responsibilities confronting us, I say again, the question has become one of what are we going to do about it? And hopefully we're going to hear some good answers to that question today from our panel. Thank you very much.
Thank you very much, Peter Thompson, for that fantastic guidance to us. So now the floor goes to Professor Nyanji Jiao to speak about global ones. Just look at this.
Hello, everyone. I'm very glad to be here to introduce the UN Ocean Decade International Program called Ocean Negative Carbon Emission, or ONCE in short. So we know climate change is the biggest environmental issue we are facing today. And the major cause for global warming is anthropogenic CO2 emissions. And the term negative carbon emission is the opposite word of emission. So that means once the carbon flux of negative emission equals the emission, we're going to reach carbon neutral. So to reach carbon neutralization, what we can do, in addition to the land, we have the ocean. I mean, the ocean is the biggest carbon reservoir on the Earth. The size of the ocean carbon reservoir is about 20 times that of the land and 50 times that of the atmosphere. So it's huge. So the ocean played a very, very significant role in regulating climate change in the history of the Earth. But nowadays, the current ocean has already stored about 93% of total CO2 in the Earth. So it's going to take some risk if we do further negative emission without fully understanding what's going on in the real world. So that's why we have this UN Decade International Program, the Global Ones. So the Global Ones program is designed toward the UN SDG number 13, 14, and the 17th. And we have 5 missions: innovative research, research infrastructure, construction of the research facilities, and the ONE's approach, demonstration in the field, as well as international communications like this, and of course, science education. And now we have 78 teams from 33 countries joining us for the Global Ones program. So before we take any actions, we need to understand the mechanism for carbon sequestration in the ocean first. Currently, the known mechanism for carbon sequestration in the ocean are these 4 camps. That's a biological carbon pumps, carbon-based counter pump, and the solubility pump, as well as microbial carbon pump. So for the solubility pump on the right, that depends on the differences of the partial pressure of CO2 in the atmosphere and the surface ocean. It's automatically taking place in the real world. Sounds good, but not that good, because that can cause the ocean water acidification. So that's not good. We have to keep that in mind. And for the carbon-based counter pump, although it can store carbon, inorganic carbon in the sediment for a long, long time, but the process can produce CO2, which is such a lots amount, because that's about the equivalent amount of the CO2 of the carbon sequestered by the carbonates precipitation. So we have to face that problem. And for the biological pump, that's a good one, which depends on the photosynthesis in the surface water, and then the particular organic carbon sinking down to the deep ocean and even down to the sediment for barrier for a long time. But if we look at the flux of the organic carbon buried in the sediment, that's very, very little. It's about 1% and even 0.1% of the total carbon fixed in the surface of the ocean. So where is the rest of the organic carbon gone? Of course, the majority of the organic carbon is ultimately respired by biogeochemical processes and back into the atmosphere. That doesn't help with the mitigation of climate change. But still, there's another part which is in a dissolved form in the water column. That is called RDOC, refractory dissolved organic carbon. That's a huge carbon reservoir because the ocean is big, right? So the scientists know the existence of this RDOC reservoir for a long time, but the scientists did not know how it was formed. So the American scientists published a paper in Nature many years ago about the formation. It is called enigma. But about 14 years ago, we proposed a new concept, which is called microbial carbon pump, or MCP in short. The MCP refers to the microbial, ecological, and physiological processes that transfer organic carbon from labile states to refractory states. Being refractory, it resisted further decomposition by the biota and other processes, so it can stay in the water for a long time. Actually, the RDOC residence time in the current ocean is about 5,000 years, so that's a long time. And this MCP is different from the other mechanism because all the other mechanism depends on vertical transport of carbon from the surface to the deep ocean and even to the sediment. But for the case of MCP, it stores the carbon in the water column, in the water body, so that's different. So now we need to apply all of these mechanisms for practice, for carbon sequestration in the ocean, either in the water column or in the sediment. the hypothesis is that all these mechanisms, all the carbon pumps, they are existing in the real world. They are taking place simultaneously. So we assuming that there's interactions and especially synergetic effects of them between each other. And if we understand the process and the mechanism behind the phenomena, we could control the boundary conditions for maximum output of carbon sequestration in the forms of inorganic, organic, and living, even living and non-living forms. So that could reproduce what had happened in the history of the Earth. You may ask me, do you have any evidence? The answer is yes. Look at the rocks. These black rocks are actually formed by induced by microbial process. If you look at it under the microscopy, you will find that all these rocks are induced by the microbial processes. And you can also test this out in the lab, like this. See that? I don't have time to go to the details, but believe me, everybody can try it out in the lab. So the rest is the key for practice is to find the right place to put this theories, this understanding into practice. And I would like to recommend civis culture area, sea farming area, like a civis farming area, which we need the food, right? But that has impacts on the environment, right? So by applying the wise approaches, we could while so more carbon in the water and in the sediments, meanwhile we can remediate the environmental issues. So that could make things for good. Because we can apply all of these pumps, including biological carbon pump, carbonated counter pump, microbial carbon pump, and a solubility carbon pump together. So we can put the initials of these pumps to become BSIMs. And BSIMs, the term also means business community management systems, which is good. And we could call this is a smart approach. And smart also can be considered as a specific, manageable, achievable, realistic, and transparent. So we could there's a potential for us to make a best practice for people to follow. And that's one of the examples to make good use of the sea farming area for negative carbon emission. Another case is, as mentioned by Peter Thompson, Professor Dr. Peter Thompson, to make good use of the sewage treatment plant, which is the source of CO2, right? And which need lots of money to run the sewage treatment plants. But by applying the wise approaches, including the microbial process as well as the alkalinity enhancement, we could make that the carbon source to be a carbon sink, and which can be sold for carbon trading to make money. So that sounds great. And the test so far we did, it's very successful. And because this is treated in the wastewater treatment plant, you have everything under control. After you made sure it's okay, you release the water into the natural environment. Remember, this is the fresh water that can spread up on top of the seawater. So that makes the largest area to suck the CO2 from the atmosphere. So that drive the solubility pump, So all the four carbon pumps are included, integrated. So these are the two examples. And then the thing for people to follow is you have to scientists, we scientists have to provide them with the protocols, even standards. And I'm very glad to let you know, we already have got a working group on ocean negative carbon emission and carbon neutralization approved by the ISO, International Standardization, International Organization for Standardization. So it's a good news. So all of you are invited, if you're interested in this area, you're invited to contribute to your techniques, and we can develop it into the standard for people to follow. Then the last but not least, the mission is science education. We have launched a common course called Habitable Earth, where we have all the experts to give the lectures, and we have the students on site, and that also made available on the internet. So I'm sorry. We have the video. We have the video how to make it happen. Can anybody click the keyboard to make it? Excuse me, sir. Can you click the keyboard to make the? I don't have the control. Yeah, we have a video only 1 minute. No? All right, we can pass it. And then this is also a video, and then show you we have the AI, I mean artificial intelligence, to help us to translate the language of the course into 30 languages. So made it available for people from everywhere, almost all over the world, to learn this course for science popularization. With that, I would like to give my sincere thanks to all of you for your attention, and you're welcome to join us. Thank you very much.
Thank you very much, Nyanji. I'm very sorry about the videos because they were absolutely fantastic, but trust me, they were good. So the next speaker will be Leonardo. Leonardo, the floor is yours now, and you're going to speak about the Ocean Vision's decade activities, including global ecosystem for ocean solutions. Okay. Oh.
Yeah, no, it's working. So I think it will be faster if we. Yeah, perfect. Thank you. Well, thank you for the invitation to this event and for all your work to the Ocean Decade, which has been a wonderful initiative. And I'm here to talk about the global ecosystem for ocean solutions in particular. But to start, I'll just say I represent here Ocean Visions. I'm the Director of International Partnerships. Ocean Visions is an organization that was created to accelerate the translation and to catalyze innovation through existing and understanding all the gaps in ocean sciences to achieve new solutions for the climate crisis, and also understanding that the climate crisis is an ocean crisis. So very interlocked, we need to find coordinated action in this space. So what we do, we facilitate collaborations, we create open source materials, so open access, so for any innovators, for any scientists to understand what's the state of the field, and to also understand where are the gaps, where are the unknowns. So what we do, to the point that Vladimir was making earlier, we work both in understanding what are the potential positives, what could be a contribution of all these methods, and also understanding what could be the risk associated with them that we need to understand better and we need to mitigate. So, and also very important, we are a network of 25 institutions, Ocean Visions, most of them leading oceanographic research institutions in North America, also in the United Kingdom and Italy. Now, what we do at Ocean Visions is this work to figure out what can we do additional to address the climate crisis, and we do it with a comprehensive strategy that is composed of 4 parts, the 4 R's of our work. First, we work on ocean-based pathways for decarbonization, then ocean-based pathways to remove carbon pollution from the ocean, from the atmosphere, and then we have a repair program that's dedicated to understanding what we can do to repair critical marine ecosystems for climate stability. And then we have a REACH program, which is where we are contributing to the Ocean Decade to enhance capacity and to increase research activities around this area. So today we're talking about negative emissions technologies, where it's specifically in this area work on marine carbon dioxide removal. This is one of the products of Ocean Visions, where you can understand some of the pathways under exploration. The reason we do this, to guide innovation, to understand what is moving, what are the most advanced techniques right now, and what are their limitations as well. So in that line, we produce roadmaps. Roadmaps are one way to also guide this process of collaboration, so there is a clear understanding of where are the gaps, where are the limitations in terms of social licensing, and any other fundamental problems to solve before there is any possibility of deployment in the future of these activities. The Global Ecosystem for Ocean Solutions is Ocean Vision's contribution to the Ocean Decade, where we are accelerating collaborations, but now with an absolutely global ambition. So we identify initiatives, we collaborate with them, and we increase also exchanges among them, among like both project partners, but also across different countries and different communities working on these issues. So how do we do it? First of all, this is all about like building partnerships, then supporting the development and scaling of new initiatives, and also leveraging the impact at a global scale. So something that works in one area, figuring out where else it can work, who else should be involved. So in a very inclusive line. Then one of our main kind of flagship initiatives is the Ocean Climate Innovation Hubs. What we are doing there is to create collaboratively new communities working on ocean climate solutions in different parts of the world. Our initial focus has been in Latin America and Africa, and I can tell you a little bit more about that if you're interested. It's one area where we need a lot of support collectively. We also have a program of fellows who are leading now figures in this case in Colombia, Kenya, Tanzania, who are working to create enabling conditions to create new research initiatives in their home institutions. And the Global Ecosystem for Ocean Solutions is a collaborative initiative that has, we have partners in more than 30 countries. We have more than, I think we're now at 32 project partners, and we are in 5 continents. So this is one of the most ambitious and largest, at least by number of programs of the UN Ocean Decade. And today here we have 2 partners who are contributing to the Ocean Decade with their initiatives, and I will be very, it makes me very happy that you can hear what they have to say about their work. So there are some key negative emissions, I put it in that language, GEOS projects, and there you can see the list, but I'm running out of time, so I will leave it there. Thank you.
Now I have the pleasure of giving the floor to Noah Olenik, who is representing the Rewind organization. And Noah, then you have to basically start clicking on yeah, you have a clicker there. So right, that's your first slide.
Thank you, Vladimir, and thank you everyone for coming. So my name is Noah Olenik. I'm co-founder and chief sustainability officer at Rewind. We're a marine carbon removal startup with quite innovative solution in the marine field. So our method called organic carbon sequestration in anoxic marine environments, or in short, marine biomass storage, MBS. We understand that plants are really amazing in capturing CO2 from the atmosphere, but once they decompose and die, they actually re-emit the carbon that they captured. So if you find a good place to preserve them, you can preserve the carbon for a really long time. And what we do, we collaborate with farmers and forestry managers. We enhance their sustainable practices. Then we collect the woody residue and ship it to the sea for anoxic water basins. Anoxic water basins are really special because below certain depth, they are depleted of oxygen. Then you don't have multi-organisms to break down the biomass. And then when you place it at the seabed, it can preserve for thousands of years and more. Actually, this method is quite innovative in the world. There are a few scientists that are working on it, and we are one of the only companies in the world that developing it. We started our own protocol. We're working with Puro and Isometric on their marine biomass storage protocols as well. So this is a field that's actually just getting to get more and more tractions. We did many field trials and experiments. And because we believe that there is a huge potential for climate mitigation with this approach, we wanted to take it one step further and to create the first Bucharest workshop for this method that will bring together the brightest minds in the field to collaborate, to understand what are the knowledge that already exists in the field, what are the challenges, and how we can bridge these gaps. So this program will be hosted in Bucharest, as I said, in this February 2025. And we're really happy and excited that it's endorsed by the Ocean Science Decade. Why did we choose to create this workshop in Bucharest? First of all, you can feel my excitement about this method. I think that this has a really huge potential for climate change. Second, the Black Sea itself, it's the biggest water basin that is anoxic around the world. So there you have the biggest potential for climate mitigation. And then we want to bring everyone to the heart of the solution and to build scientific and social support, to bring everyone together to the table and to have this discussion, but also to raise the funding for the research afterwards. And currently, there is no other workshop in the world that someone is doing. We understood the vacuum, and we just wanted to fill it in. In the workshop itself, we will bring international group of scientists. We will bring people that will speak about all the experiments that we already conducted, the knowledge that they know, and also how we can bring the gaps. And after these 2 days of working together, we will have research proposals. The hosts of this workshop are really amazing scientists. One of them is Professor Raven from University of California. She's really pioneering in anoxic environments and carbon sequestration. She published many great papers about it. We have also Professor Stanica, who is the head of GeoEcomar, who is the leading marine research institute in Romania. And we have Professor Angel from University of Haifa, and he is also an expert in marine ecology with decades of experience and also chief scientist at Rewind. So I'm actually really happy to share that currently we have amazing group of people from the Black Sea and all over the world, from multiple institutions and many fields. And I know that we have many scientists here in this room, so if you're interested, feel free to reach out to us and we can see whether we have space. We would love to collaborate. And the outcome of the workshop will be to have this book filled with many great papers, both on our experiments plans. What are the gaps, and as well the solutions that we want to bring for the permanence and the sustainability of this method. We want to share it with the scientific community all over the world, and actually to create broader collaborations with grants and just experiments in different marine environments that are anoxic in the globe. I want to thank you all for being here and promoting the ocean health and to promoting climate mitigation. And if you have a way to support us in this important initiative by funding, by collaboration, by being a great and smart person to give us the feedback, so we would love to hear from you. And thank you very much.
Thank you. Thank you very much, Noah. And Yernar Selibayev is going to now present to you the work of Caspian Eco, also focusing on various ways of reducing carbon dioxide through nature-based solutions adapted to the local area. Yernar, the floor is yours.
Thank you very much. Hello? Hello. Thank you very much, Vladimir Eduardovich, for giving me a possibility to speak, to give the Caspian accent to this venue. My name is Yernar. Yeah, I am Chief Executive Officer of Caspian Environmental Consortium. We came here from the eastern shores of Caspian Sea, actually right here, from Kazakhstan. We all know that there is 100 years of documented history of biodiversity loss in Caspian Sea. But it all starts with the oil. In early 19th century, the first major discovery of Caspian oil was made here in Baku. Then in Soviet area, a large deposits of oil was discovered, and then Kazakhstan became the oil-rich country. But what we have now, as a bioremediation practitioners, we faced all kinds of oil contamination, including 100 years old. So we have 15 years in oil pollution bioremediation with our own bioproduct, microbiological product called mica oil, and with our own technology. And when we work, actually, our microbes oxidizes oil and release CO2. And this was the starting point of our search for what we do with CO2. And we was happy enough to find the solutions. And here you see our scope, our broad vision of adaptation of Caspian region to climate change. The first is bioremediation of oil-contaminated ecosystems, when we have a broad open. So we also doing the climate litigation. We were mobilizing society to protect the biodiversity and useful productivity of different agrophytocynosis. Then we have our Caspian CDR project that we started in 2023. I will talk about a bit later. And we have another core initiative is educational. So what about Caspian CDR? Actually, we have Caspian Sea eutrophied. We have a lot of pollution, man-made pollutions. And we was happy to find that there is a solution that being developed by Rafael Jovin and Toby Boatman from Brilliant Planet. Actually, they are working on the Atlantic shores of Morocco, and we found similarities between Atlantic shores of Morocco and our eastern shores of Caspian Sea. We have arid environment, we have eutrophied seawater, and after 1 year of extensive research, we actually we're very happy to announce that we have our support from Rafael Jovin. It's official. We are doing bioprospecting now of Caspian microalgae. Here you can see the aquaponds that actually, this is carbon dioxide removal itself. The large amounts of microalgae are cultivated, and then this biomass they buried underground. And this is one of the highest quality CDR that we are now researching. Speaking of our support and our program, in 2023, in April, I wrote the email to Nyadi Jiao, and we was very lucky to receive the answer. Nyadi Jiao actually invited us to Global Once with me as executive committee member. So later in 2024, Leonardo also reached me out and invited to join the Ocean Visions and be part of Ocean Decade. And now we are the only project of Ocean Decade from landlocked countries, and then the second from the Caspian region. So I'm happy to share this this session with these incredible people. Thank you very much.
Click once again, please. No, I mean on this, yeah. And one more, and one more. Okay. So now you see on the screen all the participants, their names, and you know we have 12 minutes 30 seconds for questions. So the floor is open for questions, and you know, just a short commentary from me is that you will see basically also an ecosystem of solutions that are in the minds of leaders in this field. This is what Decade was able to produce, but basically my understanding of that is of the progress in this area is that only by communicating, by opening the best practices, by making all the work transparent, it will be possible to come up with safer solutions that may be practically implemented. Also in the result of advancement of science, like discovery of the microbial carbon pump that Professor Zhao is famous for. So best science, best communication, openness, honesty, that's the way forward. So the floor is yours, and I would like once again to say, you know, this is what is proposed. Then there will be another session starting in half hour after the finish of that, where the risks will be discussed. So only by attending the two sessions you will be able to understand the pros and cons. So, questions, please, or comments. The floor is yours, and someone has to give the microphone, please. Yeah.
Thank you. My question is for Professor Zhao. So great to hear about those 4 carbon pumps. Do you have any recommendations or examples how you can actually make all those 4 carbon pumps work in sync?
Thank you very much for the question. If I understand your question correctly, you are asking me how to do that, right? So I show you 2 cases. One is in the sea farming area. We could use artificial upwelling driven by clean energy to bring up the high nutrient water from the bottom of the area and to the surface for the photosynthesis more efficiently. You know, without this process, you know, the distribution of nutrients are not really even. The bottom, the nutrients are too much. It causes eutrophication. While in the surface layer, because the photosynthesis is very, efficiency is very high, the nutrients could be limiting during, the daytime. So by clean energy driven artificial upwelling, it brings up the high nutrients to the surface for high efficiency carbon fixation. So that's one of the example. And for another case like the hypoxia area, we could also fix this problem or mitigate this problem by the downwelling, which is also caused by the upwelling because the composition that brings oxygen-rich water down to the deep water. So that fixes the hypoxia problem. So that means by doing that kind of action, we could enhance the carbon sink while remediate the environment. And that's the one example. Another example is actually more effective, which is use the wastewater treatment plants for water treatment, including alkalinity enhancement. You know, the wastewater treatment, the effluent of the water is usually with a lower pH than the natural water, usually below 7. That's not good. So even if we see water acidification in the ocean, that's still, the pH is still about 8. So by adding some alkaline minerals, we enhance the pH, and then we release the water into the natural environment, especially in the sea. And then this high alkalinity water will suck the CO2 from the atmosphere into the ocean. And then the currents could bring this carbon down to the deep water for long-term sequestration. So that kind of manipulations. Of course, during this process, the 4 carbon pumps accelerated, including the biological carbon pump, the microbial carbon pump. Especially in the wastewater treatment, the microbial process is very active. Yeah. And also a solubility pump, which is thought to be it's impossible to drive the solubility pump normally, but by enhanced alkalinity of the water, it can be accelerated. So that's 4. Yeah. And also the carbon is a carbon pump, because this is the counter pump. But by enhancing the pH, the components of the carbonates is not really bicarbonates, which support to be the major components. In that case, when you have 1 more of carbonate precipitation, you're going to release equivalent to CO2 back into the atmosphere. That's why it's called carbonate counter pump. By adding alkaline minerals, this is changed. So it's not really released that much CO2 back into the atmosphere. So that's the operational approaches.
Okay, thank you. Lisa, please, and then.
Hi, I'm a benthic. This is Lisa Levin, Scripps Institution of Oceanography. So I'm a benthic ecologist, and I notice you and pretty much everybody else just draws this straight, flat line on the bottom, but there's ecosystems down there that are presumably receiving the carbon. I mean, in the Black Sea, you pointed out there isn't anything, maybe no animals, but I wanted to know for Nanjing and once, what is the receiving environment you're talking about, and how deep is it? Because if it's below the seaweed farms, in coastal waters, won't that carbon be recycled by the animal life on the seafloor and make it back up into the atmosphere? Do you have a deep repositories planned, or what?
Yes, that's a really good question. That's really practical. And before, usually the aquaculture area is in the shallow water, within 15 meters or so. But now we are developing marine renting system, which really go very far in the open water. It can be 50 meters deep. So then the water is actually naturally stratified. You have different layers. So normally that prevents the cycling. So this is a different scenario from the other, the past. So, I mean, when we have the principles, I could make up it like 5R, rational, and reasonable, and reliable, and also reproducible, and reportable. So if it cannot meet the requirements, we don't do. We just study one step by step.
Thank you very much. There was one more question. 4 minutes are left.
Hi, thank you. I'm Kristen Kleisner from Environmental Defense Fund. I had the Ocean Science program there, and I had a question about how much of the research that you all are doing is focused on efficacy versus the impacts. It's kind of related to Lisa's question. But there's obviously a lot of basic science that's needed to understand the efficacy side, actually what's drawn down, especially on the biological MCDR approaches. But there's much to understand about how these approaches could impact food webs, and I'm wondering how much you all are doing on that, on understanding implications for marine species or sea life on the benthos and things like that.
I think it's maybe Leo, you could start, and also Noah, and then Nyanji will finish as well. But because it's more or less clear for Yernar, I think.
Yeah, no, I'll just be very brief. So we definitely approach that. It's one of the areas of inquiry. One of the latest initiatives that we have is an environmental impact assessment framework that we have. Like we ask for an open call for proposals to just develop this over the next couple of years. And every pathway that we are exploring has this component as well. And there are other organizations. Let's give you an example, Seaworthy. that are looking at this issue in a broader way, and those who are like really focused on the MRV side, they are producing a lot of new science, and in particular for kind of a more global mapping of the issue. I think there are many organizations working on it. So I think it's part of the inquiry.
I would say that half of our company are scientists in different fields, so we are trying to tackle any type of concerns or focuses that they might bring out. Also, we have scientific advisory board in different domains, and for example, in the workshop, we invite also people from expertise in the ocean, but also social NGOs, environmental NGOs, and we also, as I previously discussed about the protocol that we published, so when we quantify 1 ton of carbon removal, we also do the research about the sustainable practices for farms, for forestry, what are the counterfactual for replacement things. So we do a lot of work in all of the domains, and we always welcome feedback.
I would like also to add that this work is not only voluntary. This work has to be included in the governance of this new emerging activity. This BBNJ treaty that is hopefully will be ratified will have positions on environmental impact assessments and things like this. But I truly think that the principle of primum non nocere has to be implemented as the guideline for all these types of activities, and I would say equal investment in the understanding of the risks and potential impacts should be made, not only even more probably before we go forward with those techniques. More questions? We have just half a minute. Burning question. All right. So indeed, this is a burning question. What to do with climate, what to do with carbon in the atmosphere. I would like to thank the wonderful team for presenting openly what they're doing. They open their hearts to you. They're trying to solve the issue. Let's just see how we can move forward and be honest to Mother Nature. Thank you.